Right, in part 4 of our series on strings, we're going to look at C-string library functions. So there's a special then library. We're going to include the header file string.h, and there's lots of functions already written in order to make string handling easier for us, right? In part 3 video, we actually ended that video by writing a function that calculated the length of a string. Right, we're going to see that there is a string library function that handles this. So I give you a reference here to this page, particular page. I find this website very helpful, cplus.com. So let's then go ahead to that web page. Here, let me bring this up, right? So the C-string library here on this web page, this lists all the functions within this library found including string.h. So if you include this header file, you can access all of these functions. Right, so concatenation will find is adding strings together. There's functions for copying strings. There's functions for comparing what's in strings, searching what's in strings, setting the memory. Here under other, strlen, string length. So get the string length. So I'm going to click on this. Right, it's going to take me then to that reference page, and let me make this a little bigger. Right, we're going to see the function prototype here. So the function's name, strlen, string length. Right, it then requires one parameter, and that's going to be a constant data type constant char star, and we're going to pass it a string, and it's going to return to us then the number, the length in the string. The data return type is size underscore t. Size underscore t usually relates to bytes. Well, chars are 1 byte, so when it tells us there's 11 characters in the string, it's almost referring to 11 bytes. But it's going to tell us how many characters are stored in our string. Right? And this tells you then that string length should not be confused with the size of the array that holds the string. Here in this example, then they made a string that can hold, right? They allocated 100 chars for memory. This has 100 elements, but when they initialize it with this, you can see, well, test takes up 4, there's a space, 5, 6 for string, so probably 11 spaces, right? And then we take a look. This says it defines an array of characters of size of 100 chars, but the C string with which my string, the variable has been initialized, has only 11 characters, right? So if you were to call size of my string, that would return 100, because remember, size of tells you how many bytes are allocated. Well, that means it allocates 100 bytes. But if you want to know how many of those bytes are used, right, in the string, you call string length, and that will return 11, right? And then, so it'll return the length of the string. It always gives you some example code here that you could run to see then how long the string is. All right, let's go. We'll run that in just a second. Here it shows you that if you enter this information, what you'll get out. So I love this website. It always gives me some code I could run. But let's go back then. I'm going to pop up code blocks. In part 3 of the lecture, we ended with this example where we wrote the code ourselves to calculate the string length. Let's just go ahead and run this so we can see its behavior. Remember, we can type in a string. So I'll just call this test string here, right? And we see this returns 11. Test is 4, the space is 5, and then string with 6 characters long. All right, let's take a look. This example is very similar. Then our array is called MSG, but we allocated 100 here for that. Right? We went ahead and used gets to read that from the command line. Sorry, not from the command line, from standard input. And then we use a pointer that we point to the start of our array, and we use this pointer to walk through, and we keep saying, let's go through the array until then, when we use the indirection operator with pointer message, until we reach the null terminated character, let's just add 1 to the string length count. So we wrote our own string length function. Right. If we were to replace this with this example then from cplus.com, now notice here, because we're going to use a function from the string library, we have to include string.h, the header file. Here we're using the string length function, so we're going to call that. So you can see then, here's an array that's created. SZ input is the name of our array. Then its size is 256 bytes in memory. Right, we're going to enter a sentence. Will then store whatever words we type in, and it'll tell us then the sentence entered is will %u. Well, because this returns then a size underscore t type, that is an unsigned type. In this case, they're specifically typecasting it to unsigned, right, and using the %u with this. Right. So let's just go ahead and build and run. And once again, if we do test string, which we saw with our other program had 11, we get 11 characters here as well too. Right. Similarly, if you'd rather put something like this in a variable, if you're having a hard time seeing what happens when we call this function here, right, we could create a variable then here. Let's make it size underscore t, that data type. And we'll just call this length. Right, let's initialize it to 0 so it has a known starting number. That's not real important. And what we could do here is we could just say let's assign to length. Then we call strlen. Right, we pass it then the name of our array, which in this example is SZ input. Right, and then here we could just simply, instead of calling this function, say, right, I want you to then output the variable we have stored in length. All right, that builds. We can run that. And so we'll get the same behavior if we say test string, test space string, we get 11. All right, so if it's a little bit easier for you to see that you call a function, store something in a variable, and then print that out, that's just an extra step there. But you can see that you can call the string length function. It'll return then the length. Let's put in some different size strings. So this is a sentence, right? And even if then, right, we type some other characters in there, it's going to count all of those characters, right? It counts the spaces, it counts the digits, so it counts everything we type, right? In this case, it gave us 25. And so even though we wrote that function earlier, it's handy then. We don't always necessarily want to write all the functions. It's handy to use these functions that are in the library. So then that is our string length function. Right, this slide refers to its prototype. It returns the length of the string. Right, it'll read everything until it gets to the null terminator, and it does not count the null terminator as being part of the string. And that's what we've observed. Right. And then here's another example that I gave you. You could go ahead and initialize this to a string and print out its message. So once again, another example showing you how to call string length. It's going to return some unsigned information. You need to include the string.h file. All right. But let's take a look at another copy, like string copy. So let's say we want to copy some information from one string to another. Right. So the prototype of this function, strcpy, it requires two parameters. The first parameter is the destination string. So char star, right, a pointer to where you want to store your information, your destination. Const char star is a pointer to the source. You want to read it from the source and write it to the destination. So when we read from something, remember the const modifier makes this area of memory we're accessing with this pointer source read only. So it's going to then point to that, and it's going to copy that into the destination, including the null terminating character stopping at that point. Right, to avoid overflows, the size of the array pointed to by destination should be long enough. Meaning, right, if I'm going to copy 10 characters from here, this should be at least 10 characters long. Actually, if I'm going to copy 10 characters, including the null terminator, this should be 10 characters long. All right, so you want to make sure that you always allocate enough memory for what you're working with. Right. So let's take a look at this example then of how we could use string copy. And all right, let's copy this code out of here. All right. So we've got hello in message 1, goodbye in message 2. we're going to print out what's in message 1 and what's in message 2. And then what we're going to do is we're going to say, let's take what's in message 1 and copy it into message 2. And what that's going to do is it's going to overwrite from the start of message 2. It's going to overwrite all of the characters. So we'll overwrite the H with the G, the E with the O. Because there's more characters here, we're then going to see the same, what looks like goodbye, or I'm sorry. We got it backwards. Source into destination. Source was hello. We're going to copy hello into string 2. Let's take a look at this line by line, what this does. All right, so let's run the cursor before the string copy. All right, so we can see message 1 has hello, right, followed by the null terminator. Message 2 has goodbye, followed by the null terminator. Now, if I call the string copy function, so I'm going to say next line. So what that's doing is it's copying what's in message 1, my source, to my destination. So what it did was it copied the HELLO. It copied then the first null terminator over here. Basically, it wiped out, even though this string was shorter than the goodbye, as soon as we put that null terminator in there, it wiped out those other characters. When we access message 2 now, we're just going to get hello. If we say next line, right, we pop this out, we see that we have hello in both of these. So it simply allows us to copy that information from one string to another. And it starts at the beginning of the next string, simply because here, right, message 2 is a pointer to the start of the next string. Message 1 is a pointer to the start of that string. So what you might want to think about is, in order to understand how these work, it's best to write your own program that performs these actions. Right? If you write a program that performs these actions, you have a better idea of how these functions work, along with going ahead and playing with these functions a bit. Right? So what would happen here if I said, I want you to overwrite? What if I change the pointer from message 2 to message 2 plus 1? Message 2 plus 1 should point to this first O. So let's go ahead and do a run to cursor. Notice then after string copy, I said I want you to copy that information in starting right here. So we retain the first G. But you don't always have to give it a pointer to the start of the function, or the start of the string. If you do, it will overwrite then the whole string. But if I give it a pointer somewhere else, then it will only overwrite that portion. Similarly, what if I said here, what if I wanted you to start at message 1 plus 1? So plus 1 is ELLO. Right? And if we build and run here, right, we can see then all we get in message 2 is ELLO, because I said to start at the second character and then copy the rest. So you can play around with these pointers a little bit to overwrite portions of strings. You don't always have to start at the beginning. Right? You need to make sure it's going to fit within the memory space. Let's take a look. This was 0, 1, 2, 3, 4, right? So at plus 5, let's go ahead and say, I want to take message 2, and I want to overwrite that at message 1 plus 5. So index 0, 1, 2, 3, 4. Plus 5 should be right after hello. So run the cursor. Actually, sorry, this is still running from the previous example. Run the cursor here. Right. So notice then what I did was I copied goodbye, because message 2 points to the start of this string. I said take that and copy it into message 1 plus 5. So basically added that on to the end of that string simply because I use this offset notation. So like I said, we can copy portions of strings, we can copy the entire string. It all depends on what your pointer values are here. Right. So if we get back to the notion of us taking what was in message 1 and copying it, overwriting message 2. Right, let's think about how we would write a function to do that. Right, so let's create a char star pointer. So I'm going to call it pointer to message 1. And I'm going to set that equal to message 1, which is the start of that array. Char star p msg2. I'm going to point that to the start of message 2. And now if I say while, use the indirection operator, p msg1 is not equal to the null terminator. I want you then to store that. So in message 2, I'll use p msg2. Right, and I want to store p msg1, that character in there. And then I want to increment p msg1, and I want to increment p msg2 to point to the next spot. So if I don't use string copy, if I do that, and now if I can say after my own string copy, so if I move this down here, I want to print that out. All right, well, let's just go ahead and check my logic. So run to cursor. All right, so we've got message 1 and message 2. We've got these strings in here. All right, p message 1 is pointing to the start of this string. P message 2 pointing to the start of this string. So I'm going to use the indirection operator to read the character where this stores. So this is going, first time it'll read, and this will return an H. The H character is not equal to the null terminator, so this test will be true. So now we're going to overwrite in p message 2, we're going to overwrite with the H. We'll increment each pointer to point to the next array element. Right, the E won't be the same as the null terminator, so we'll just overwrite then the O with the E, increment our pointers. We'll step through here. Right, we still aren't at the null termination of the first string. And so we'll overwrite the next character, increment our pointers, and you can watch us step through here. Right, we're writing the O in this case. Right, incrementing the pointers. Now we will point to the null terminator of the first string. So we stop. Right, now something's a little bit different than string copy, because when we got all done, because I had not in here, I had not explicitly said to put the null terminator. So what we're going to see is we still have, we say next line and pop this up. All right, we can see we have hello, and then we still have the YE of goodbye. So if we want to perfectly mimic that string copy function, we also need to copy in that null terminating character. What we should do here is we know in this case, right, that PMSG1, this pointer points to the null terminator. What we should say now is PMSG2, and use that indirection operator one more time to overwrite then there with then the null terminator. So PMSG1, which should be pointing to the null terminator, right? And so this should say add null terminator to MSG2. Or we could have directly written something like, let's just go ahead at that spot and assign it the value of that as well. All right, this loop should have failed, right, simply because this was already equal to this, so I'll just use the indirection operator with this to assign it to that, rather than use the character constant. And so now let's do a run to cursor here. All right, so now that we're through here, when I make this assignment, right, now when I make this assignment, we can see we put in that null terminator, and both strings are going to give us the hello, right? If we run that printf, we see we get the same results. So that was a way then for us to go ahead and write our own string copy to mimic that same behavior. Right? So mimic that same behavior of copying the whole string. Right? Similarly, if I did something like, let me just start this at the second character. When we did that before, we'll see that we retain the G, and then we just put hello after that. Right? So if we do a build and run here, just like we did in that other example, when we started playing with the pointers, right? When we said point to the next index, we kept the first character. Similarly here, if I just said, oh, I want you to point to the first character, right, and overwrite the string with part of that, right, we get the ELLO in this case in the second string. So work with these examples, work through, see how these pointers work, see how you can play around to pick up certain portions of strings, right? If you want to just copy part of the string or the entire string. And as we've seen, then we use then string copy before to implement that. Like I said, most of the time we want to use these library functions that already exist for us. But in order to really know how they work, you have to sit and play with the pointers and have an idea of how this works, to learn how it works, right? So you can see what portions of strings, and a really good idea is to write these functions yourself. All right, here's the third. There's several functions in the string library. So besides then string length, string copy, this one is often used concatenation. Concatenation means we're going to append a copy of the source string. So our source string will be appended to the destination string, right? So append usually means we're going to write to the end of the string. The null terminating character is the destination. In the destination is overwritten by the first character of the source, and a null character is included at the end of the new string formed by the concatenation of both. Right, so we're just going to add this on. But what we'll do is let's take a look at this concatenation example. You can see here that if we type hello and goodbye, or sorry, not type, they're stored. Hello is stored in message 1 and goodbye is stored in message 2. That after we call this string concatenation, then the message 2 is going to have hello and goodbye. We're going to take whatever's in message 2 and basically add it on to the end then of hello. So let's then just go ahead and copy this into our code. All right. And we build this. We do a run to cursor. All right, we can see then message 1 has hello, message 2 has and goodbye. We can see that before calling the function strcat for concatenation, message 1 had hello, message 2 had and goodbye. Notice we're only going to overwrite then the destination because message 2 is read-only. So strcat. So now we can see that message 1, we added on to the end of that and goodbye. Right, message 2 is still the same. Right, we print those out. We can see message 2 didn't change, but message 1 had that string added to the end. Right, we call that string concatenation. So we can put then multiple strings together with string concatenation. Right. Now, if we started playing around, if I said, well, my source is message 2 plus, let's see, if I don't want the and, there's 1, 2, 3, 4. All right, so if I say, so this is index 0, index 1, index 2, index 3. So what happens if I say message 2 plus 4? All right, if we build and run, notice then we got hello, goodbye. Right, simply because I changed the pointer. I said where I want you to start reading in message 2 is at index 4. Which happened to be this character, and then add that onto the string here. So hello, this string, right, has 5 characters, 6 characters because of the blank space in it. Right, so like I said, it's going to add on to the end of the string. You can see as you adjust pointers, then it will then actually just pick portions of the string. So what you should do right now is, now that you've seen string concatenation and you've seen how to loop through with pointers, you should write your own string concatenation function, right? Use these same examples and see if you can get it to behave in the same way. And so if you want to think about it, if you're going to write your own string concatenation function, we saw that what this does is this starts at the end of message one. It starts, the end of message one, remember, is indicated by the null terminator string. So you're going to have to find out where the null terminator is here and start at that place inside of message one and start basically copying in message two and adding that onto the end along with the null terminator. All right, so that should be an exercise that you should try on your own. Right. I wouldn't be surprised if it appeared on a quiz someday, so that's good motivation to write this. It might show up in homework, so go ahead and practice writing that one. Write your own string concatenation. And like I said, there's lots of other functions in there. So there's a substring function as well. So this looks like str. I think of it as string. What this does is it will go find, so string 2, it's going to go find a pointer to the first occurrence, right, of whatever we have here in string 2 in string 1. So basically, it's going to search string 1 to see if it has the same substring or same set of characters. So string 1 is a string to be scanned. String 2 contains a sequence of characters we want to match. Okay. Now here's an example here. We have this message 1, right, that has stored, this is the message in here. And then I'm going to call then the string, the substring, the string function. I'm going to say I want you to search message 1 for this literal, the word the, and it's going to return a pointer then to that particular string in my array. Let's see how this works. Oh, well, I'm going to pound include string library and standard IO or printf. All right. So let's run the cursor. No, sorry, I still have the old example running. Now let's run the cursor so it rebuilds. All right, so now we can see message 1 has this is the message stored in it. We declare this pointer, right, to a char. We call then this substring function, string strstr. We say, we want you to search for this sequence of characters. The sequence of characters is THE, and I want you to search this string, message 1. And what I want you to do is it's going to return a pointer to where that sequence begins. All right, so after we run this, so next line. Right, so now PTR points to the T. So it always returns a pointer to the start. So when it finds then this sequence of characters, it returns a pointer to the start. So now if I were to just say, well, give me the string where message 1 points, that's what we're doing here. This %s says, give me the entire string for message 1. This now says, give me the string for PTR. Well, since PTR points to the TH, right, we'll get the message printed out, right? We print out the whole string. Let's again run the cursor. Right, we can see that message 1 still gives us points to, this is the string, pointer points to, if we address the whole string, the message. Right. Now, what happens if our string isn't in there? So let's stop this. So what if we said we wanted to search for, actually, so we want to search for the word for. We can see the word for isn't in there. All right, let's run the cursor. Notice then this function, when it can't find your information, returns a null pointer, which is this hex value of 0. And now if I were to print this out, I would probably typically crash my program. What I'd want to add is I want to check to make sure this wasn't a null pointer. All right, if I just go ahead and say next line, well, actually, this was kind enough, since it returned the null pointer, to actually print out null for me, simply because this was a string. I was lucky. If I was trying to do math or access other areas of memory, I'd be in trouble. So a better technique would be to say something like, if PTR is not equal to null, right? Go ahead and print this out. Else, maybe I want to use puts or printf. substring not found, right? Because it's simply because that substring isn't in there. So now we're searching for 4. We can see we get the message substring not found. In the case where we were searching for THE, we knew that was successful. That word's right here. Right, it prints out then what both of those pointers point to. Now, if we're searching for TH, it's going to return the first occurrence. Notice the first occurrence of TH, well, it all depends on, is this function case sensitive, right? Because here's lowercase th, so let's build and run. And notice that it is case sensitive, right? Because we were looking for a lowercase th. If we were to change this to an uppercase th, it should return this. Then we should have both of these should end up pointing to the start of our string and print out the entire string. They do. All right, now we have 2 instances of the word is in here. So what if I say I want to search for the substring is? It should return the first one it finds, which is this one. So we should say is the message, right, for that second pointer. All right, so what it does is now PTR points to this first instance of is in here. So it returns the first instance it finds. And so, like I said, that can be handy. Similarly, you could write a function to search for substrings. You're then going to have to do some comparison between arrays, so that one is a little more difficult to write. As always, I encourage you to try using, and you'll learn a lot by trying to write these functions. Go ahead if you'd like that extra challenge. Fine. All right, and now talking about comparing strings then, right, there is a function then that we often use for string comparison. We want to see if one string is the same as another. So we're going to pass then to this function named strcmp, string compare. We're going to pass it 2 strings, right, which are going to be read-only. And it's going to then start comparing each character. So it compares on a character-by-character basis from left to right, if they're equal to each other. So if every single character is the same, right, it's going to continue until it reaches then a different character or a null terminator, right? And it will return a value of 0 to indicate that both strings are equal. It's going to return a value greater than 0 if the first character that does not match has a greater value in string 1 than in string 2. Otherwise, less than 0 indicates that there was a character in string 2 that had a value greater than string 1. Let's look at some examples of that. Okay. So let's just pop this code in here. Copy this into code blocks, and let's take a look. All right. I don't need those. Includes twice. All right, so we're going to compare here. String compare, we're going to compare apple to apple. These should be the same, so it should return 0. Well, let's just run it and talk about what it returns. All right, so here, notice then, right, apple to apple returns 0. They're exactly equal, but apple to APPL returns 1. Well, the character E, if we bring up the ASCII chart, is greater than, so this would have the null terminator as 0. The character E has a decimal value greater than that, so this would say apple is greater than APPL. In this case now, APPL compared to apple, so string 1 is less than string 2 because the null terminator is less than this E where they differed. Right, these two obviously differ immediately in the first character, apple and orange. A compared to O. Well, A happens to be less than O, so this returns a -1 to indicate the string is less than. Orange compared to apple, well, since O is greater than A, it would return a 1 since the first character where they differ is greater. Right? Now, we usually don't use greater than or less than. What we're usually searching for is equality. Right? We're looking to compare 2 strings to see if they're exactly alike. And so our greatest usage for string comparison will be to see if that returns a 0. So what I want you to remember out of this unit is for string comparison, when it returns a 0, your strings are equal. You'll be using that in homework. You'll be tested on it, quizzed on it as well too. So remember the equality comparison. We're not going to care about the greater than or less than. If you want to play with it and learn about it, of course, I encourage that. The important thing for your homework and your exams is understanding that when two strings are equal, string compare returns a value of 0 to us. All right. And there are other functions in that string library. These are the ones we're going to commonly use in our homework right now, so I haven't covered all the others. But, go ahead and go to that reference page and play with some of the others if you want. As you work with strings, you'll find some of them handy to use. But for purposes of this course, I expect you then to be able to use string compare, search a string for a substring, so strstr, right? And then concatenation, strcat. I want you to be familiar with that. These are good things to write on your note cards. String copy, how does that one work? And then string length. Right, string length is important as well to know that. All right, and that's the end of this lecture section. Right, our next lecture then will be talking about arrays of strings.